Hi kids, Mr. Wagner here again for biology, going through the last two sections today from our bone notes. Notice that some of these answers may be in the book. There are book scans that are available in the folder here for this last part of your notes, but some of the answers may be here, some of them may be there. So if you can't find them in one place, look in the other, all right? Bone types, let's talk about those, different types of bones. Maybe, there we go. There are four categories of bones. There are long bones. They support the weight of your body. They work with your muscles. An example would be the humerus, the ulna, the femur. There are short bones. They're as wide as they are long often. Examples would be like your carpals or your tarsals. Think of them like almost like cubes or squares, things like that. There are flat bones. These are used to protect vital organs. Your ribs would be a flat bone. Cranial bones, your sternum would be another flat bone. And then finally, irregular bones, bones that do not fit into any other category. And the main one of this is going to be your vertebrae. They're neither long, they're neither short, they're hollow, they're weird shaped, they're special. So four main categories of bones. This is what a bone looks like. In fact, there's going to be a diagram just like this on the test. Notice that the sides of the bone, the ends are called, or one end is called the epiphysis. The ends are called the epiphysis, and then the center is called the diaphysis. The diaphysis is like the shaft part of the bone. The epiphysis would be like the rounded ends. Notice that on the epiphysis, there is spongy bone in the middle. In the diaphysis, you have the medullary cavity. That's again where you make and produce red blood cells, white blood cells, store fat. There's a periosteum, which is a covering on the bone. There's compact bone in the diaphysis. Notice that it's solid, it's sturdy, it's strong. And then finally, at the very end of these epiphysis, usually there is articular cartilage. And what that does is that adds a little bit of cushion and support. If we got bone simply rubbing up another bone, that's going to scrape away eventually and cause problems. That's what causes arthritis. So this extra layer of cartilage, articular cartilage, kind of helps cushion and support the bone, giving it a smooth finish so it doesn't scrape against something, because bone is pretty hard stuff. Make sure you got this diagram down. It will be on our test. Anatomy of a long bone. Again, so this is a long bone only, of the epiphysis and the diaphysis. Interior, there's the periosteum that we talked about. The outer covering of the bone contains blood vessels. The compact bone, which is the outer shell, strong and dense, gives the bone strength and rigidity. And then the spongy bone. This is lightweight and porous. Porous means water can go through it. Looks like a sponge, but it is also very strong and rigid, but it reduces the weight of the skeleton. Remember when we had our birds? Birds had hollow bones. Why? Because it reduced the weight so that they could fight against Earth's gravity when they fly. Same thing here. This gives a little bit of strength still, but it also reduces weight, so our bones are not completely heavy and weighing us down. Inside the marrow, the medullary cavity runs through the middle of the bone shaft. It's hollow, contains red marrow in children and yellow marrow in adults. Red marrow produces red blood cells. Yellow marrow stores fat. In adults, red marrow is found in proximal limb bones like the sternum, the vertebrae, scapula, ribs, and pelvis. Main areas there. All right, and let's also pull up, while we're at it, our next notes, which are going to talk about joints. Bone classification and design. Did we do that one? That's the one we're talking about now. This is also going to be joints as well. Bone classification and design. Let's do that. All bones of made are osteocytes. Anytime I see that word osteo means bone. So if I'm a osteotrician, that means I'm a bone doctor. Orthopedics is another one. Osteocytes are arranged around a Haversian canal that contains blood vessels. The Haversian canal contains blood vessels. The hardness of the bone is caused by the hydroxyapatite, which is a stronger than concrete. Collagen in the bone prevents the crystals from being pulled apart like reinforced concrete. Reinforced concrete is concrete that literally has metal bars running through the middle of it to help reinforce and strengthen it. Same kind of thing here with our bone. Actually stronger than concrete. Compact bone has cells packed very tightly together. Spongy bone has struts that run through it separated by spaces. Bone is designed to break down old cells and build new ones. Osteoclasts, these are the bone destroyers. They remove old material and the bones and release stored minerals. Osteoclasts, bone destroyers. And then the osteoblasts. Blasts are my bone builders. I know it says growers here. I want you to think bone builders. That's going to be a little alliteration with the blasts, bone builders. Osteoblast, bone builder. Responsible for the growth of new bone cells, and it also stores minerals. Bone renovation keeps our bones strong. As we age, the renovation process slows down and bones begin to become brittle. Between the ages of 30 and 40, osteoblast activity decreases. Important nutrients for your bones are calcium, phosphorus, vitamin A, vitamin D, and vitamin C. Calcium and phosphorus form the inorganic parts of teeth and bones, but they need a vitamin. Deficiencies in vitamin D. Vitamin D. Very often your milk will be fortified with vitamin D. If I don't get enough vitamin D, I get rickets. That's when the bones bend under the body's weight. They're kind of like rubbery and soft bones. If I don't get enough vitamin A, it retards the bone development, and it doesn't develop fully. If I don't get enough vitamin C, this prevents the osteoblasts from producing enough collagen. Slender and frail bones when that happens. I get slender bones and frail bones when that happens. Physical exercise can affect bone growth and development. When a bone undergoes stress, they strengthen. So whenever you stress a bone, it gets stronger. This is Wolff's Law, 2 F's, Wolff's Law. Bones adjust their shape to the physical stress placed on them. So what does that mean? If I'm constantly running, then my leg bones are going to get stronger because I'm putting stress on them. Lifting weights, etc., will increase bone density and strength. Lack of stress, that is doing nothing or being in zero gravity, being in a cast, will decrease bone mass and strength, which is why it's so important for astronauts when they're out there, they don't have any of that gravity pulling down on their weight of their body onto their bones, and their bones can get very weak. So it's very important for them to do regular exercise in zero gravity because it's not good for our bones. Fractures. A fracture is a break or crack in a bone. A simple fracture means the bone cracks or breaks but doesn't pierce the skin. A compound fracture is when the bone actually gets sticking out through the skin. Those are the gross ones that you do not want to see. Compound fractures. Types of fractures. Transverse, that's when a bone just breaks clearly and true. Trans means across, it just breaks right straight across the bone. A green stick, that's where the bone cracks and bends, but it's held together by collagen. A spiral, that's when the bone is twisted in half and breaks with a twist. Comminuted, this is when a part of the bone is shattered. And an avulsion is when a piece of the bone is broken off. An avulsion. Piece of the bone broken off. Repairing a fracture, here's what happens. Bleeding occurs at the site of the fracture and a clot forms. So let's say I break my arm. Bleeding is going to occur at the site where the bone break happened, or the fracture, and a clot starts to form. The spongy bone unites the inner surface and the cartilage stabilizes the outer surface. Cartilage gets replaced by spongy bone. Osteoclasts, those are the destroyers, remove the dead bone. And osteoblasts, remember those are the bone builders, begin to form new bone cells. Spongy bone changes to compact bone. It can take 4 to 12 months, There may be swelling at the site, but there's usually no other sign of a fracture. Here's what's important. Repaired bone is usually stronger than it was before it was broken. Repaired bone is stronger than it was before it was broken. Let's talk about joints. Joints are placed when bones articulate. So where they articulate, that's another fancy word for the joint, or where they come together. 3 main types of joints are immovable joints, cranial bones, that's when my bones are just sewed together and they don't move. Slightly movable, like the vertebrae, I can move them a little bit, but not a lot. And then finally, the freely movable or synovial. That would be like my elbow, knee, finger, etc. Those are my free movable or synovial joints. So here's an example of what a synovial joint looks like. There's a membrane, there's cartilage in between the two, and there's a joint cavity filled with synovial fluid. Joint cavity with fluid. The fluid makes them rub past each other smoother and cleaner, less friction. The ends of the bones are covered with articular cartilage. We already talked about that. The bones are connected with ligaments. Remember blab, bone, ligament, and bone. A joint is lined with a membrane and surrounded with a capsule. The synovial fluid lubricates the joint, kind of like oil or WD-40. And a bursa will provide padding to decrease the friction. A bursa. Sometimes if people have problems with their elbows, it used to be called tennis elbow. If people played tennis a lot and their elbows got really sore, a fancy term for that is called bursitis. Anytime you have an itis, it's usually an inflammation or swelling of the whatever before. So if I have bursitis, it's the swelling or inflammation of the bursa, which is the padding used to decrease friction. Types of synovial joints. Ball and socket. Only two places in your body you have a ball and socket. That's in your shoulder for your arm, and that's in your hip for your leg. That's why my shoulder can go all the way around and do 360. I can go this way, pretty much all the way around because I have a ball and socket. Same for my leg. My leg can come up and down and out and back and forward and all the way around because here's my socket, here's my ball, and as it goes in here, notice I can move just about any way I want within that ball and socket. Yep. Second kind is called the hinge. That would be like my elbow or knee. That's simply where it just goes back and forth, up and down. A saddle, that's found in my thumb. That's the perfect example for a saddle joint, my thumb. The ellipsoid would be in my finger. A pivot would be in my neck. And the gliding would be my scapula or my clavicle. Those would be a gliding joint. 6 kind of joints, and we'll give you a picture of what each one looks like. There's my hinge, simply goes up and down. My pivotal simply can rotate. That would be like in my forearm with my ulna and my radius. The ball and socket, found only in the leg and in the shoulder. The elbow would be an example of a hinge joint. And the pivot, the leg would be an example of a pivot. And in the shoulder and in the hip are the only 2 places for the ball and socket. We got something called the condyloid joint. That would be like in my wrist. A gliding joint. That would be like in my tarsus. And then the saddle joint, that's like in my thumb. So it slides back and forth. So no examples of all those. I might have pictures of these different joints, like a picture of what the gliding joint looks like, and have you match up with the gliding joint or the saddle joint. All those, and I might even have examples, so just be aware of that. Joint problems. Degenerative conditions. Degenerative means to break apart, especially when you get older. Arthritis. Maybe your grandparents talk about arthritis. This is an inflammation of the joints. Of anywhere where it articulates. Remember we had their articular place where things articulate or joint. So arth, it would be my articular thing. And then itis is inflammation. Inflammation of my joints, usually in your fingers. Osteoarthritis, wear and tear across the joint to become inflamed. Rheumatoid arthritis, the body's immune system attacks the joint. Sports injuries, you can get a sprain. A sprain is a stressing of the ligament. Remember a bone, ligament, and bone, blab. A dislocation is when a bone pops out of alignment. A torn ligament can cause a severe sprain. That's when actually the ligament, the things that connects the bone and bone together, actually tears. And those are my examples. All right, make sure you got your notes filled in. You'll need them for future assignments. Otherwise, this is all of our notes for bones. Take care and God bless.